Okay, I have to run.
It's time.
Yeah, let's go. Good morning, everyone. This is the ROR meeting. Thank you for joining us. We are about to start. Yep. Okay, this meeting, it's attached to the not well. Please be aware of that. Okay, our meeting material. Thank you very much to Dominique for minute taker yesterday and today. Yeah. Come forward. And thank you to Michael for being the JavaScriber. Fine. Okay, this is the agenda for today. We hope to have an exciting meeting like yesterday. Okay, Charlie's not here. So, let's come in. Okay. Do you want to present your topic first? Because he's not. Pascal? Please. Thank you very much.
Thank you. So like I said, I was with Charlie at the IETF coordination, so he will arrive in like 10-15 minutes at most, so don't be afraid.
No.
And with this, since it's Friday and we've got time, I will tell you a story. So it's a IETF info. Once upon a time, there was this desire to have a simple IoT device in a very big room like this with many quote-unquote access points on the ceiling or something. And the device would just, like a Wi-Fi device today, move across this room. And without having to change its security associations, without having to form new addresses and renumber and everything. Charlie, I took your slot because you were not there, but I promised you would. You know, I took my risk. So you just skip the slot.
You can also present my slides if you like.
Oh, come on.
No problem.
Well, actually, then what's coming is partly yours. So we had this dream of having a very, very small IoT device with a very, very simple implementation roam across a room like this, or even a room which is 10 times bigger than this. And just doing 6LoWPAN and getting your layer to write, this device could roam in the room without even caring that there is a route over mesh that covers the room, or multiple route over meshes with a backbone covering the room. All this working smoothly with seamless mobility. The guy attaching to a 6LR and then to the next 6LR and then to the next 6LR and getting all the time connectivity back. So basically we're talking about a device which attaches, in our case, to a Ripple network, so we call it a leaf, but it's not even Ripple aware. So for the sake of this document, we will call it a Ripple unaware leaf. So there is this sad acronym of RULE. We can change it, please let me find a name, but it is a Ripple unaware leaf. Some Ripple has the concept of leaf. A leaf should be fundamentally aware that there is Ripple, even if it's not forwarding. A Ripple unaware leaf is sitting at the edge of a Ripple network and doesn't have to know about it, which means that the simple interaction it will have with the 6LR using 6LoWPAN should be enough for Ripple to forward the packet all the way to the root, and should be enough for the root to do ND proxy for the device if there is a backbone. So actually, that doesn't take a lot on the Ripple side to achieve, but it took a lot on the 6LoWPAN to achieve. So my long story, my Friday story will be all the steps that take us to this situation which looks so easy, where you've got this simple IoT device doing simply layer 2 access and then 6LoWPAN ND roaming across a very big room with many routers, many route over meshes, etc., without caring about all this complexity. the story starts, so you may want to read that one of those days. How much time do I have? Half an hour. So please read those sort of things. This is kind of the reasons why we ended up doing all this work. But I won't have time today. So I will start with the work that we had to do on ND. I won't be as complete as I was yesterday at 6low, but I will show you what we had to do in ND so that we can make Ripple's work possible to actually allow this device to roam across multiple Ripple geotags without even knowing about it. So the first big thing we had to do is change 6LoWPAN-ND. And the reason why we had to change 6LoWPAN-ND is that a device that moves across a fabric must provide, there must be enough information for the fabric to figure out what is the latest location of that device. There are two classical ways of doing this. The first way is the fabric captures a very precise time of when the device is seen, and then compares, if there are multiple places where the device has been seen recently, compares the most recent, finds the most recent timestamp. The problem with that approach is that the mobility of the device can be very slow or very fast, and the amount of space and the precision of the timestamp can vary a lot. So it's very hard in an IoT situation to find the right unit for a timestamp and the right precision of the timer and expose that. So what Ripple does, and what now 6LoWPAN-ND will be doing with this change, is that the source keeps a sequence. So that's the AODV's destination sequence number, if you like. That's a number that the IoT device, the 6LN, has to maintain because the routing will need it to figure out the most recent location. So now, when this new work that we are doing here, Ripple and Nowhere leaves, acts on behalf of this device, it will have a sequence number which will allow to find the freshest location of that device in the network and set the routing appropriately. So that's a big change we made in 6LoWPAN-ND. There are others I will show you. Second thing we are changing in 6LoWPAN-ND is source address validation. There are two aspects in SAVI. So first aspect is when somebody forms an address, if he's the first in the network, he should own that address. That's ND. But the question is, can somebody steal that address with the current ND flows? That's very easy. You just expose the same address, now you get the traffic. So on powerful devices, the IETF has defined CGA and SANT, which are FC 3971.72, and that enables to protect the address against theft. But it's a very complex protocol. It's mostly implemented. Nobody's implemented but Cisco, I guess. And the last third document in this description is the backbone router. If you take 6LoWPAN-ND, the first document, and the backbone router, what you get really is the layer 3 equivalent of a .11, 802.11 association. Meaning, if you figure out what really .11 does with an association, on wires, when you're looking up somebody, you just send a broadcast over a spanning tree. Well, the old fabrics, right? You send a broadcast over a spanning tree, and that fills the transparent bridging state, the source of this broadcast, we know where it is, along the spanning tree. Now, that's okay on wires. That was never okay on radios. So what the Wi-Fi did when they developed their radios, and they said, hey, we cannot have all this spanning tree transparent bridging flooded over my radio. So what I'm going to do is the device will proactively set up a state on the AP, which actually is a bridge. And now the AP will know whether to copy over a multicast over the radio or not, because he already has proactively a state which tells him you need to do it or not. And we had the exact same problem on our LoWPAN devices. We didn't want to have all those broadcasts. So what we end up doing with the RFC 67 and the update is a registration process in 6LoWPAN-ND, which is very much equivalent to the association. And the equivalent to the transparent bridging operation is done by the backbone router. So this is the guy which will do ND proxy so that you look like a normal ND device over the Ethernet backbone. But still, like an association, the backbone will know when to copy you, and the rest of the time you won't get all those multicast. So that's what this series of drafts do. And I will just tell you the changes we did in the update so as to serve REPL. But it's not just so as to serve REPL, it's so as to serve any routing protocol which behaves a bit like REPL, supports mobility, so you need timestamps of sequence counter. We'll see that we have a sequence counter, and you need a lifetime for getting a state in the network. So we see how we did that. On the side, we changed from 6LoWPAN-ND, we changed the length so as to have a larger field, which used to be UI64, and now we call it registration ownership verifier. And that's for the savvy part, so I won't be speaking too much about it. The only thing I want you to think about the savvy part is now we can protect the address of the owner on the 6LoWPAN space, but we cannot protect it on the REPL space, meaning that we don't have any proof as we send the DAO over the DODAG that the DAO talks about a device who's really there, that it's not somebody who has stolen the address. We can only protect it on the first hop with the APND draft that I just discussed, right? So there might be interest in future work so that you're sure that what you're exposing in your DAOs is actually true. Right now, we just know it in the first hop. So if your first hop is retrusted, then you're okay. Now, if the first hop could be a trick, then anything still could leak in the REPL fabric. And that would disrupt routing. So right now, we've done it on 6LoWPAN, we've not done it on REPL. The way we did it in 6LoWPAN is with this proof of ownership token we call the rover, and we have changed the length so we can have bigger tokens, so we can have more security. This bit is of utmost importance, and that was discussed on the role mailing list, the R bit. So in 6LoWPAN-ND, this field, which is now the R bit, was reserved. And current REPL implementation, which do REPL and 6LoWPAN-ND as they should, well, they are, since it's a reserved field, they will set it to 0. So when we discussed whether we needed this bit and who would set it, we realized that we did not want to change the bulk of REPL implementation. It was rather easier to change the devices which would implement this new spec, the 6LN which would implement this new spec. So the R bit is not set by routers, and it is set by hosts implementing this new spec. And what it means is, if there is a routing fabric, or if there is some proxy activity or anything else, please do it for me. Make sure to get my reachability, because I won't be doing it myself. So a REPL router will always set the R bit to 0. And the 6LN, which doesn't participate to the routing, doesn't even care if there is routing, mesh under, just proxy ND, because it's attached directly to an AP on the backbone, it will set the R bit. That means, do it for me, please. So when we do the new support we have, we'll be doing it only if the R bit is set, okay? The TID is a sequence counter. Actually, the text in the specification is copied out of REPL because we want the implementation to be simple with the most deployed current protocol. So we said, hey, let's have the exact emulation of the REPL sequence counter handling, which is an info in the transit option and is called the path sequence. So this TID has the exact same description as the path sequence. You can take a TID coming from a REPL unaware leaf and stuff that in a DAO as the path sequence. Now, we'll change slightly the text to say that, but people do not want direct reference because the 6LoW people are very keen that this spec is not dependent on REPL. Right? So it's an exact copy of the text. You can use it with the current REPL specs. That's Rahul.
Rahul Jadhav, Huawei. So just one point stuck to me, the path sequence is not a mandatory field that goes in the DAO.
The path
it's not mandated by the...
It's not, yes, it is. It's in the target option.
I don't think it's mandatory option.
Oh, we have to look at that. Yes, I mean, you can't do that. It is. I mean, the path sequence is not an option. It's a field in the target option.
Yeah.
And yes, it is mandatory. If it's not, we have something big above us, because that's how you resolve any movement in Ripple. Check it, please.
Okay, I'll verify. Okay, thank you.
I mean, without a path sequence, you're dead. It's like AODV without a destination sequence. Then the next field of interest for us is the registration lifetime. Now we have a slight problem for the implementation, because the registration lifetime in ND is a constant. Well, the unit of it is a constant. It's minutes. Ripple was a bit more far-sighted than this, because we have a configuration option where we tell what the time unit is. So now in the DAO, we can express the time with less bits, because there is a multiplier of some sort, which is the time unit. So since it's not the same unit, when you want to match a DAO, when you want to match a registration coming from a 6LN and turn that into a DAO to get reachability for it, you will have to do the unit mapping. There's no way around it, because ND was like that and we wanted backward compatibility. Raul, why don't you sit next to the mic, Raul?
Yeah, I just verified it. So it's part of the transit information container, but transit information container is mostly used only in case of non-storing mode of operation.
No.
It's transit information by itself is not a mandatory option, a container, right? That's what the spec says.
But if the spec doesn't match the transit information, then it's a bug. But it has to be there, because that's how you refresh your routing, or it must be a should or something. If you don't put it, your routing is mostly screwed unless you have a very fixed topology.
Yeah, I'm just saying that at least 6550 currently doesn't state that transit information is mandatory.
Okay, look at that. Well, there's the should and there's the must, but it should be a should.
The reason why I know about this is because when I experiment with most of the open sources, none of the open sources currently use path sequence. They don't use path sequence, they send path sequence, but they don't really act on the path sequence. And we had a discussion on the mailing list. I remember you said that the path sequence is used to clear the downwards route.
No, that's the TSN. Oh, what are you talking about? The path sequence says it's supposed to, not to clean the downwards, it's supposed to update. Well, okay, there are two actions when you have a path change, right? One of them is easy, set up the new path. That's what the path sequence does. And on the current parent, you will clear the old, everything related to the old sequence. But then there is this action of pruning, which is new to your draft, pruning all the path. And that's new job, but.
Yeah, keeping that aside, because in my draft, at least I don't talk about path sequence at all, because it doesn't, I talk about path sequence, but it's just a part. So if I take the base Ripple specification, you're saying it has, if transit information is not mandatory, it has to be mandatory for this.
Nothing much works if it's not there, right?
Okay.
Unless you have, you know exactly what you're doing. You have a very, very fixed topology where you don't even have a lifetime, right? The lifetime is in the transit information.
Yes.
So I mean, if the must is missing somewhere, it's kind of a stupid miss. But the transit information must be there. I mean, the whole Ripple flies away if you don't have it.
The spec says that transit information may be present in the DAO messages.
Okay, I'll look at it. Okay, because that's a good point. That let's not spend a missing on it. Transit information is there, and if the implement, okay, very big message here. There are some quick and dirty implementations all around. I won't give names, but don't use that as a reference of what Ripple is. Don't write a paper saying Ripple doesn't work in this case because that particular open source implementation, which was done by somebody who was not there, doesn't work, right? There's more to Ripple than a particular, I would say, quick and dirty implementation found on open source. We are still lacking a real reference open source implementation of Ripple. So registration lifetime, same thing, goes into the transit information. That's how Ripple knows how long to keep a state for this particular route. And we map it from the registration by the device. But as I said, we have to change the unit. And this is just the X UI64 field. Ripple doesn't need it for now, but if we define a way to trust hop by hop the DAO information you're getting, in storing mode, or if the LBR and the root talk together in non-storing mode, which is hopefully what they do, then we can actually trust that what we're seeing here is true. Like the DAO having is the same guy. You can correlate the non-storing DAO with the DARDAC message. Okay. So just to give you a hint of normal boot of a network, so here I've got a network with a backbone router. So this is a traditional Ethernet, whatever switch network, say, running traditional neighbor discovery. This is the backbone router doing ND proxy. And this is all one big fat subnet. So this room, like I said, this factory floor, this huge thing, is one big fat multi-link subnet with single/64. Why? Because you want seamless mobility. You don't want to form a new address going subnet to subnet. And if it's a different PAN, changing all your security tokens and everything, rejoining. Oops. So you've got this big fat backbone. And what 0FC6775 slightly updated do is, well, the array will carry some information like the prefix you're using in this /64. It will also carry information about the border router, that's about the LBR, who is the LBR. And this is new. The new spec mandates a 6CIO option, which is RFC7000, blah, blah. And that tells you some bits that you can expose in the array about capabilities. And the capability that we'll have here is support by the 6LBR and by the 6LR of this new spec, right? So when we build a network which will take leaves and do the REPL for them, everybody must support this spec. So you must have a 6CIO, and the 6CIO must say, hey, I'm supporting this spec at the 6LBR and at the 6LR. And that's how we know we can play. From there will be the 6LoWPAN registration. A few things changed. The biggest change is in traditional 6LoWPAN ND, the registration is for the source address of DNS. But that was a problem when we want to do the proxy registration by 6LBR, who happens to be the root, normally. We'll discuss that. And the 6BBR, because the source of this NS here has to be the 6LBR. So if that was what you are registering, you would be screwed. So what we are now registering with the update is the target. You know, in the NS/NA messages, there is a field called target. Usually that's what the message talks about. Well, we made that consistent with the old or other ND specs. What the message talks about is the target. What is being registered is the 6LoWPAN node here. Okay. And by the way, we made it clear that you don't do that for a link local, because the link local is used by this pair here. The 6LoWPAN node, the 6LN, could be talking to a different 6LR with a different link local address, right? And it will work, this discussion here, as long as this guy has only one node it talks to with his address, and reciprocally, this guy has only one node it talks to with this link local address. So the link is really those two guys talking together. That's what the link becomes as a scope for link local address. If that's so, then the uniqueness of the link local of this guy is what this guy sees. So you don't have to do any big flow like DARDAC, right? It's a locally managed. You could say the same thing if this guy here has a /64. So in some deployment, you could say, hey, I have a big /64 for all my network, but I also have a specific ULA for H6LR. In this case, you would not have to go all the way to this LBR because it would be the 6LBR for his own prefix. Okay, so there's no need to have one LBR for all the prefixes which are around. Each prefix has its own LBR. So after a timeout, you see that the backbone says this address is unique, and then the NA ERO for the proxy operation turns into a DAC message, turns into an NA ERO. Peter?
Hello, Peter van der Stok. I have a question about backward compatibility. If I have 6 LRs which know about the update and 6 LRs which do not know about the update, will there be something going wrong? Will that mean that you cannot have any non-ripple aware nodes available at all? I mean, what will
Okay,
the situation be?
That's a great question. There is text at length about coexistence and backward compatibility. Basically, it's okay.
Thank
The
you very
answer
much.
is
I'm
it's
reassured.
cool, but the spec says if you know by a 6CIO if the 6LBR supports it. If the 6LBR does not support it, you can't do any of the security thing, right? Because you better have larger keys. Even if the hash of the key, I mean, it's easier to attack if the hash is shorter than longer. So that's why we want to extend the size. So the security aspect is really weaker if you don't support the new spec. Now, the doc says if you see both, attach to something which supports the new spec because you'll get more services. If you have no choice, then you can attach to a 6LR, but you know by the 6CIO that it's a 6LR, the classical one. Then you know you cannot do any of this, right? So basically that's it. Now, if you attach to a 6LR that supports it, and on the Ripple path there is a 6LR that does not, you're okay. As long as the 6LR you attach to and the 6LBR both support it, you're all set. You can have normal routers on the way, but you should be able to see a 6LR which does this, otherwise you're screwed. You can't get the service.
Okay, fine.
Right?
Thanks. Yeah.
Okay, so basically the response of this flow, which is, one hop, multi-hop, DAR message, duplicate address request, mapped into by the 6LBR into an SRO to feed the 6BBR, get the proxy state in place, and back. All this is now described. Okay, it's a combination of operation by the RFC update and the backbone router, which explains really how the proxy works. So the signaling is in the update document. How you do the proxy operation is in the backbone proxy spec. And this is under IESG review. There were already many comments. So we are going through them, and there is nothing that hurts too much. And we really thank all the reviewers that we got. Adrian did it for the routing area. So we had some exchanges. It's not closed yet, but we are very close to closure, I guess. So this the RFC 6775 update, as far as I see it, is very close to RFC editor now. So this is fantastic news because this group can leverage this spec to do the famous Ripple leaf unaware work. So that's why I started it. So I won't talk about APND, but if you want to look in more detail, that's how we do the validation of the address. So that basically, as I said, gives you two things. That gives you the capability to form any address you want and get it protected later. So nobody can steal your address. You're still the only owner. And the second thing is that the 6LR now can see packets coming in, and if the source is not the owner of the address, it can filter out this packet because it's not topologically correct, quote unquote. Right? So that protects the owner of the address against somebody else impersonating him. And that protects the network and the rest of the world against somebody sending a packet which is sourced at an address which is not him. That's traditional source address validation stuff, savvy. Okay, so we're working on the crypto, blah, blah, blah. Like I said, the most important piece that we need to know right now is only the first hop is protected. Ripple is not. Then the backbone router, again, I won't speak too much, just show you this flow. So there was a discussion yesterday about whether the DAOAC is local or global end-to-end or not. Let me be very clear, it's local. Right? It has always been local. Then again, open source guys can play with their implementation, do what they like, but it's not the protocol. If it's not clear in the protocol, we talk with Raoul, we need to clarify the protocol. That's how a spec goes into the internet standard level. Right now, Ripple is not internet standard level. We need to refine this sort of thing so that it becomes internet standard level. So we'll do mailing list exchanges to explain things about Raoul's documents. Maybe we'll turn that into some small documents which explain better or things like that. But yes, the DAOAC is a local acknowledgement. Whether you use the lower layer acknowledgement or you send a real DAOAC has a significance. If you use a lower layer acknowledgement, then it really means that you trust that you will never lose it between the MAC and Ripple. if you do a real DAO hack from the Ripple level, then the sender of the DAO knows that it was received. Now, you must be very aware when you're doing a Ripple implementation that if you hand out a storing mode DAO, the guy who acknowledges it takes responsibility. It's like a letter from the king that's being transmitted hop by hop, right? If you accept the letter, you can refuse it. You can refuse the DAO, right? You can say DAO NAC. I mean, I don't want it. But if you accept it, it means you will handle it now. Which means that you take the commitment to send it to your parent. If eventually it fails, you can not send it to a parent after rich rise and whatever, trying all your parents. It really needs that you lost connectivity. If you lost connectivity, then you need to poison, and your children who took responsibility of this will advertise it to another parent. But the case where a DAO stays stuck in the middle of the network is not supposed to exist, right? It's somebody accepting, oh, I will do that for you. I put it in my pocket. I promise I will give it to somebody. Goes to somebody's home. Somebody's not there. Okay, scratch the letter. Now, you cannot do that, right? So you accept a DAO. You take responsibility. You have to forward it up, or you have to say, I cannot be a router anymore, either way. But by the way, so that was for yesterday's discussion. So there we go, the DAO, so that in storing mode, that's multiple hops doing this. In non-storing, it's just end-to-end. So the Ripple root gets it. There is a big discussion, and we will have it on the Leaf document, whether the Ripple root is the LBR. That's an interesting topic. In the Leaf document, I showed how we could do it if they are separate. In my mind, it makes no sense to separate them. Actually, if you look at the definition of a 6LBR, BR means border router, right? The way 6LoWPAN uses the 6LBR is not as a border router. 6LoWPAN uses the 6LBR as a registry, which could be anywhere in the universe, as long as you can talk to it. But it's called the 6LBR. And it makes a lot of sense that this registrar is actually the border router for many reasons. So even if I specify a show that we could separate them, it might be that this specification says they must be the same, right? We will have, that's one of the big discussions. There are not many big discussions on my document, but one of the big discussions we will have is, do we must that the Ripple root and the 6LBR are the same guy? Which is logic from the name that 6LoWPAN gave to this device. That's all I can say. And otherwise, there are additional flows which are really waste of time. So I will show those flows, but that's where we go. So that's where we are. The cool thing is, you know, this is done repeatedly every lifetime, right? You want to maintain the state, you want to maintain the registration, the 6LR, you want to maintain your DAO state in the root and in storing mode along the path. And then you want to maintain the ND proxy state. All this requires that periodically this is set. Now, remember, if normally when you have an NSRO, you must have a DARDAC all the way to the 6LBR across the mesh. That's a cost. But hey, since we have Ripple doing DAO, we can actually use the fact that we got a DAO at the root, which can coexist with a 6LBR to say, hey, Mr. 6LBR, we're okay. We got a DAO that's equivalent to the DARDAC, right? In which case you don't have to do both. So the draft suggests that in the real life, you know, at the beginning you have to do the DARDAC for the address detection, duplicate address detection. But after that, we say, hey, the Ripple root can act as a proxy for doing the DARDAC with the 6LBR. If they're collocated, it's just some internal function call. If they're not collocated, there must be additional signaling, but at least it's local to here. It doesn't have to go across the whole network. That's part of the discussion in the draft.
Let's go. 10 minutes.
10 minutes. Yeah, I'm good. I'm good, 10 minutes. No worries. Remember another thing which is expressed here, Ripple cannot do that because we cannot pass the rover all the way across. So we cannot secure anything and we cannot do anything like that. So if Ripple shows with the same TID, the same guy coming from two different directions, Ripple will keep the two possible paths. We build DODACs, right? So we're happy to have two paths to get somewhere actually. So let me skip that in the interest of time. And here is maybe the meat of the current document. So now you see the background, right? We have changed 6LoWPAN ND so that in a fashion which is abstract, agnostic to Ripple, we have all the information we need in 6LoWPAN-ND to actually populate the state in the 6LR, so that the 6LR can do ripple on behalf of the device. That's what we did. We also made it so that this can, at the other edge, the root has all information to refresh the 6LBR, avoid the DARDAC all across, and do the proxy operation so that it gets packets for the device from the backbone router, and then it will use ripple to forward it down. With all this, now we have the means to have what I said earlier in this room, have many, many backbone routers, a big Ethernet fabric connecting all the backbone routers, forming many, many DODAGs, and the 6LoWPAN device, completely unaware of ripple, will be able to roam. We'll just do a 6LoWPAN-ND update with this sequence counter in it, and there will be a new DAO in the same DAG or in a different DAG. You see the power of it? Very simple host, and yet the whole power of ripple, backbone router, everything to serve it. What do we need to do on the ripple side to get it? Well, ripple has a bit, which is called the E bit, which allows to inform, I think it's also in the target option. I mean, you can't live without it. Which basically says this is an internal address or an external address. If it's an external address, it really means, okay, it's something that was redistributed into ripple. You don't really expect ripple to be the backbone of something. It could, but it really could. But really what it's meant for is exactly for those leaves. So we knew about leaves when we designed ripple. It's just that the only thing we did for them is an E bit. We didn't write this draft because we are missing the 6LoWPAN side of it. So now we have it, and what really happens is, okay, I'm getting this registration. There is the R bit, which tells me I have to work for him, and I will send a DAO with an E bit saying, okay, I did it on his behalf, I'm his router, I'm not him. And that will help do the encapsulation above at some point, mostly in non-storing mode. That's a ripple, use of ripple draft. We can't and we don't mandate anything on the leaf because they're supposed to be ripple unaware. Still, it won't work for any host. I mean, there must be a minimal support, which is not ripple, but it is something else. So we mentioned 3 things in the draft in UC version 4, which was just published. The first thing is the leaf must support RFC 6775 update because I need all those bits and all this information, right? There are 2 other things which are not linked to the control plane, which are linked to the forwarding plane. We need to be able to decaps IP and IP, and we need to be able to ignore the RPI. Because if you look at all the ripple, the use of ripple info draft, you will find that at some point, some packet will arrive to a ripple unaware leaf, which still have some ripple information in them, the RPI, the IP and IP. Since IPv6 does not mandate that a host can decapsulate IP and IP, we have to say, hey, we'll work as long as the host does that, okay? So the other 3 things, RFC 6775, IP and IP, ignoring RPI. That's what we ask for as a prereq from a ripple unaware leaf. So there's more text about the air flag. So basically, like I said, the air flag is designed to be set by a ripple unaware leaf, which supports 6775. So if you see this bit on, it means this is a host that does everything I want. I mean, it supports 6775 because it could set the bit. And I have to do the ripple or the ND proxy for it. If there is no ripple, if there is just a backbone and you're talking already to a backbone router, since it's the same NS message that that is proxied by 6LBR or that this node does, it just works the same. So you can deploy this exact same spec with just a Wi-Fi type of ESS information topology. Okay. So the spec has must there. I mean, if the host sets the air bit, we must do the ripple for it. If the host does not set the air bit, we must not do the ripple for it because he will be doing it later. He's actually a ripple router. So I took care of showing what happens when the 6LBR is actually just a registrar and it's anywhere in the universe, and the ripple route is separate from them. Then again, we have to make this decision whether we have to support that. But I made it. The problem with it is probably that node that must be one hop away from the BBR is the Ripple root, not the 6LBR. So the node which is really the border router of the Ripple network is the root anyway. It's got to get the packet. Yeah, just 3 slides. So if we decide that the Ripple root was not the 6LBR, then it's really because we want to push the 6LBR far away in the network. And the node which is doing the proxy registration is really the root. So in all my previous slides, when you saw the 6LBR doing the registration on behalf, well, that would be the root really doing it, which means on the very initial flow, it does not happen. Or differently. So the way it would work then is the Ripple root would do a keep alive DARDAC exchange to the 6LBR on behalf of the node. But since it doesn't have the rover option, it would be more constrained one, which does not have a proof of itself in it. So I'm not too sure it's a good idea, but that's how it would work. And like I said, the node which is one hop away from the 6BBR has to be the root. So it's the one that has to do the proxy registration because the root will pass the packet to him so he can inject the packets all the way down. So you see that basically in order to get the rover to make this proxy registration, what would really happen is you send a Kepler EDOR, which doesn't have the rover in it. But the 6LBR, if it's happy with it, would respond with the rover. And now the root has it and it can do the proxy. It's kind of weird to do all this. We could, if we have a real use case, but I would like the group to actually at least recommend strongly that those two are the same guy, because the real border router is him anyway, right? So mailing list. Maybe. Yeah, and so the document also has text about what I just said. You know how you map the TID into a DAO, how you map the lifetime into DAO. And that's not me anymore. I'm done. Questions? We have 1 minute left or two.
Well, who read this draft actually? Oh, very good, because we're not representative yet. Okay.
And Michael is not there, but I can proxy for him.
Very good, thanks. Is this in any way 6-ish related? Is this draft 6-ish related?
Well, you know, 6-ish has an architecture which puts everything together. So it comes from, well, as the bigger view architectures, yes, 6-ish will use that, but there is no requirement coming from 6-ish saying do this, right? It's more 6LoWPAN actually, which told us, hey, we want a 6LoWPAN 6LN not to have to do anything special because it's Ripple. And it's because they want to support route over in general. And at least we have an example now, but what we did is 100% agnostic to Ripple. It's, you know, having a sequence number or a timestamp is how you do mobility, and having a lifetime is what you need to have anywhere in the universe. That's why the transit option is so necessary. And so we need to fix the spec.
So you're looking forward then to discussion on the mailing list?
Yes, I mean, this is a very, very simple draft. I mean, all the work was done at 6LoW. That's why, if you have waited what I presented the work at RAW in 2 minutes. I presented the work at 6LoW in like 30 minutes, because that was where all the works happened. Well, it's not finished, so if you want to work on that, come to 6LoW. The backbone router in particular is not in workgroup last call yet. But what we have to do here is so simple and so important. I mean, now you have this stupid node, very simple. Now we can have a big route over network and have very simple nodes roam into it, have transparent, you know, seamless mobility. And that's the dream we had at the beginning. So we could not do it with Ripple as initially. Now we can.
Okay. Is the terminology compliant with this Ripple info draft?
I formed the term rule here because Ripple info talks about leaf, but that was maybe we used unaware, right? Okay, good point.
Thanks.
Okay.
Thanks.
So, like I said to the question, it's a very simple draft. It's not a lot of work for us. It's something so important. It's just a little grain of sand that would make the whole thing work. So, I mean, in my view, it's something we must uppercase do.
Thank you very much.
Thank you, Pascal.
Charlie?
A bit late, but nevertheless very welcome.
You can take out the...
I kind of like it in the stand, though. How's that? So good morning. I'm Charlie Perkins. Sorry to be a little bit late this morning. I'm here to tell you about the progress with the AODV Ripple draft. And let me see, I guess that's a little bit small font to read, but basically...
It's Charlie, you can see it there.
Oh, I see, right. I know I can make this work. There you go. So the idea is basically that we're going to set up possibly between a source and a target, we're going to set up possibly asymmetric routes by using similar to AODV messages, a route request and a route reply. And although there can be asymmetric, the original intention was that there to actually be connectivity, and the reason for the asymmetry would be because of the objective function or the metric would be evaluated differently in each direction. So this seemed to be working pretty well, and we went to last call and had a lot of comments, which I will review shortly. But let's see. Well, I think I already said all of these things. So some of the comments during the last call was that it was inappropriate to have constraints on the expected transmission time without prior knowledge of the link quality. Well, that's kind of difficult for AODV Ripple to actually solve within the protocol itself. And the way that devices in the network know about their link quality is, I think it should be considered out of scope, but we could add some neighborhood messages to AODV Ripple to actually make these estimations if that was desirable. And it would be not closely related to the existing message structure. But the most, I guess you would say, extensive comment was that AODV Ripple was written more or less from a fresh start, given the charter item to do peer-to-peer networking and then allowing for asymmetry as well. But we didn't at that time go into previous experimental RFC P2P Ripple. And so some of the features in the, no, I think it's 6997, oops, go back. Some of the features were not included in AODV Ripple. And so the comment was made that that's a bad idea. We should actually not lose features so that people wouldn't, if they wanted the feature, they would have to implement the experimental protocol and AODV Ripple. So the attempt was made to actually put in the relevant features from this P2P Ripple. And I have a lot more to say about that shortly. So the instance ID, the way it was set, the route request and route reply set up different Ripple instances, and we want those to be associated for at least the purposes of reduced signaling, make this control messages smaller. Another suggestion was made to use the DSTN for the sequence number. And that, actually, I puzzled over that for a long time, and I've had discussions with Pascal and other people. And I think at the end of it, it seems that is not an appropriate use for this field, because it's actually intended for soliciting updates for maintaining the current connectivity of the graph. And another comment was made. Oh, yes, Pascal.
If I may. So there are already two sequence counters going down, just for the sake of the room, I think it's worth these words. There are two sequence numbers coming down from the root. One, and I mentioned that yesterday somehow. One of them is when you build a new geodag, and that, remember, this is all formed by diodes, right? It's not formed by DAO so far. So the sequence number you have are the DTSN and the version number. If you have a new version, it really means that you're painting a new geodag. Now, the root could also issue a new DTSN, in which case you would keep the geodag that you have, right? No new reparenting or anything, no new DAG formation, but you would be making sure that the prefixes are available. So it's really a matter of what exactly the protocol wants to do. Anyway, it's from the root, right? Because that's the one forming this, sending this reply. But whether you want to use an existing geodag and just refresh it, or if you want to form a new geodag. So for the first route reply, it's obviously using versions. I mean, that's why it is. Now, if there is a case where you just want to do some keep alive, then you could say, yes, I could just increment the DTSN and keep my structure the way it is. And that's why I asked you when we talked, what exactly is your destination sequence? Is because in this case, there is topology behind it. Whether you want to refresh the topology or just refresh the state which is associated to the current topology, like which address is reachable where.
Okay.
So there's not such a definite answer. You really have to answer me, what is your sequence number?
Well, on the subject of Keep Alive, we don't have anything for that yet. And I mean, as you mentioned, this could be helpful for that. But I think that would qualify to be a separate discussion, at least for now. And it was also suggested that we consider black hole detection, or actually unidirectional links, so that no signaling was at all was possible across that. And this actually is quite doable. And so, but it does represent a new feature that wasn't there before. So I suggest that I will put out on the mailing list a possible solution for this in the context of AODV Ripple. And I'd be delighted to put it in because I think it's useful. Okay, so this is actually sort of an expansion of what some of the small points on the small font on the previous slide. But so, for instance, we don't currently have a way to exactly tell you how asymmetric the link is, but it's presumed that the devices already have that knowledge, and we can revisit that assumption. So this is, so we don't actually tell anything within the spec about how these metrics in either direction are really, how the information is acquired. So, oh, by the way, I want to also mention that the current version of the spec that's out there was not a completely finished product. We ended up coming up against a submission deadline and felt that we had plenty of new description in the document, but there are some things that I'll mention later that you would think would indicate that it wasn't completely updated to all these points. And for that, I apologize, but I fully expect to get a more consistent version of the specification out. I was going to try to do it this week, but it's been pretty intense. So hopefully next week or the week after, we'll get a revised version with including whatever discussion happens here. Pascal.
Yes, I'm sorry, it took me time to jump to the mic, and I'm thinking of the previous point and symmetrical link, asymmetrical link. The original P2P Ripple was using the DIO as a route request and the DAO as the route reply along the geodag that was formed by the DIO, right?
Right.
And that implies that even if the links are not symmetrical, at least there is a bidirectional connectivity. And that's really a limitation of P2P Ripple, and that's also a limitation of Ripple in general. You need at least a degree of bidirectional connectivity. And I looked up everything I could about what causes asymmetry in those radio links. And really the main reason, probably the only reason, is poor hardware. where the exact setting on the radio on of both endpoints are not exactly aligned, meaning that your frequency is not exactly where my frequency is. So the things like multipath echoes, things like that, don't impact, both ways exactly the same. Now, if your radios are really finely tuned, usually they are symmetrical. Dominic will tell me now. Okay, that's what I found in my research, so I'm happy to learn more. But where I was getting at is this document, be very, very aware the big difference is that it's not using DIO. It's using two DIOs both directions. Right. And well, my feeling until Dominic fixes me is that asymmetrical link was not such a big deal. That's why we lived without, But unidirectional link, I mean, that's a big difference. So you say, yes, it looks good. I mean, I emphasize that. I think it's wonderful. I think it's actually very, very important because there are such a thing as unidirectional links, and Ripple could never cover those. And so this is the first draft that can actually do something for Ripple for unidirectional links. And yes, it's not easy. It's not hard to do because you're doing this in both directions. Yes, you should support it, express how it works, because it's much more important than asymmetrical, in my view, right?
Well, I don't. So when I joined the author team for this document, it was already 2 DIOs, and so we never changed that, and it never came up in the working group until this week. So I'm okay with trying to refashion it, especially since we're using a different mode of operation. We can redefine what we need to make the asymmetric. For instance, if you wanted to design it as DIO and then the route reply would be a DAO, that we can try to do something with that. But yes. Okay.
This will not be repeatable on the audio.
I'm just correcting what I was saying because I think I was misunderstood. I was saying, yes, keep it as 2 DIOs because you have the support of directional links. And I think you're the first work ever to support directional links in Ripple. If you went back to DAO like P2P Ripple does, then you would lose this directional thing. Asymmetrical, in my view, is less important. It was never really raised up in networks like touching, but directional, I think, is a great plus. So you should make sure it works. You should emphasize it. What you just said, I will notify it. No, emphasize it. It's important, in my view. Okay. That's what justifies the truth, yes, I suppose.
Okay, thank you. That's a good clarification. Yes. Dominic?
Dominic Bartel. Just as a comment to Pascal's comment, another common reason for asymmetry in radio links is interference. Because if you have somebody blasting in your ear very loudly, then you desensitize the receiver because the overall level rises to the, and to have less sensitivity. And so your reception is bad while your transmission going a long way is at a lower level, and doesn't desensitize the other receiver. So that's another common cause for asymmetry.
So I think as a very brief summary, unidirectional routing and link detection is important. We should develop a solution for that, put it on the mailing list, and please make comments for that. Is that okay? Thank you. Okay.
How much time do you still want?
So one of the major features from RFC 6997 was the ability to have a route request for multiple targets. And that we'll do that. The current specification provides for that, but there's a source of some bit of inconsistency, which I'd like to go into here. Well, there's a minor point. We removed the S bit, but it's now in the route request option. And an option link was added to enable, I forgot to mention an important thing, that in the new version of AODV Ripple, we also allow for source routing in addition to storing mode. So that is a source of a number of changes in the document. But eventually, according to discussions that we had, it just didn't make sense to require people to go to a whole nother specification if we could provide for source routing solution as a relatively minor modification to the existing specification text. So that in combination with the requirement for multiple targets has led to some additional stuff in the specification. So other features from oops, I keep pushing the wrong button. How about that? So we also want to have this COM compression field and talk about how long the router can be existing in the DODAG, and then also allow for this max rank field. So these were features that were imported from 6997, and we're still, you might say, verifying that it's consistent with the rest of the specification. And then again, for source routing, allow for an address vector. And then to allow for multiple targets, we have this AODV Ripple target option, which is modeled on the one in ROC 6997. Now, this brings up an interesting point. If you're going to have multiple targets in the AODV Ripple document, we defined a use of the destination sequence number, which is an AODV construction to guarantee, to essentially make it impossible to have routing loops, which is a good idea. But if you don't put it in the route request, then it means that the target has to respond. And in AODV, it's possible we designed something called gratuitous route reply, which could be provided by an intermediate device. In AODV Ripple, because of the asymmetric routing and the paired DODAGs, that turned out to be somewhat less convenient, and I'm not sure how often that would be used. So my current suggestion, and we're still under discussion, is when you have multiple targets in the target option, just to not have the sequence number. And let's see how that works, because then it just means that each target individually has to respond with the route reply. And my current intuition is that that will be okay to do that. All right, so, and then we had discussion about how it is that the instance IDs would be paired. The original document, or earlier document, I should say, just said, well, we have, if you add one to the instance ID of the route request, you get a route reply, and then occasionally there might be a collision, or even rarely, there might be a collision with the instance ID already in use at the target. So now what this proposal is to have another field that usually the ID would be, well, first of all, there's a bit here that says whether or not it's from the route request to the route reply. And second of all, if the route reply ID, instance ID, is already in use by the target, then there's another field called shift that basically says, okay, well, that one was already in use, but you can get the instance ID by shifting it to another number. So I think this is pretty intuitive and it'll probably work, but we definitely would like to get more eyes on that. So next steps, well, in my opinion, we cannot cite RFC 6997 in any normative fashion in this document, because that's an experimental document. And so any things that we import from RFC 6997, we basically just have to cut and paste the text, or copy and paste the text. So that's pretty much straightforward to do that. And then that'll be part of the new submission in a week or two. We want to make sure I'm not actually, there's a suggestion was made that it's possible if you have multiple originating nodes, in other words, the device that sends out the route request, that they could accidentally use the same Ripple instance ID for their own purposes. And then what happens if the target or an intermediate node has to deal with that? So that's going to be a case for us to sit down and actually analyze it in some detail. And that remains to be done. I'm hearing here in this meeting that it'd be a good idea for us to have this black hole link detection, and so we'll make a proposal for that on the mailing list. And then, well, whatever else we discuss here. And so I think I'm done, and I'll be delighted to take questions if anybody has.
There will be short questions and short answers.
I'll be delighted. But
Rahul Jadhav. So,
Yes.
So you mentioned that the asymmetric link detection is out of scope, or the unidirectional link detection is out of scope. I think that is, and you also tried to mention that maybe the working group can work on it. But yeah, like you mentioned, it's better to keep it out of scope. It's difficult to get a universally acceptable solution for that particular problem statement in this particular draft, I feel. What do you think?
What is it yours?
So what I'm trying to say is the actual detection of asymmetry or unidirectional links,
Yeah.
that is out of scope for this document, right? The actual
Well, it
detection.
doesn't have to be out of scope. I mean, if we need to have it, we can make it in scope for the document.
So what I intend to say is the actual probing that happens.
Oh, I see, right.
Yes.
So in other words, if deciding on the asymmetric metric is out of scope, then
Right.
deciding on, right, I see your point. I don't have a good answer for that. But it could be that we can, you might say, augment the mechanism from AODV to all. Well, why don't we put the metric information in there as well? So that could work.
Pascal Thubert, I don't even think we need to do anything, because what we're really doing is we're building another DODAG based on the metrics on the other directions. So the Reggie metrics, like the LQI, what things you gather are what you see, right? So if a link is really asymmetrical, because we're building another DODAG with another DIO, I mean, we might not be going through those links at all if they are, it's not like when you're sending a DAO, you want a DAO hack. That has
Right.
to be bidirectional or asymmetrical, but still bidirectional. Here, we are flooding a DIO across links which can flood it. And if a link is directional or asymmetrical, it won't pass or it won't go at all. And we'll build a different DODAG. That's the whole point of having those two DIOs, right? So
Well,
I don't
right.
see when you need to look at the directionality of a link. The DIO will be preferred naturally.
Yes, that's right. When you're spending all the resource to do flooding in both directions, that gives you a lot of power. I understand that fully, but we just need to be careful about it, because this is a good place to put bugs. And in addition, the symmetric bit turns the reverse DIO into a unicast, and make sure that they can handle that case as well.
Okay, fine. What I should like is that this document gets concluded. That's one of the want this work to be concluded. So if you can have this discussion on the mailing list, whether we add it or not to the document, and you can conclude within 2 weeks if it's a lots of work or not, then you see how the document concludes. Okay.
I would be very happy to make it on the mailing list.
Okay, very good.
Thank you.
All right, so I'll be presenting the performance report for the route invalidation update. So briefly, it's the current Ripple specification. This applies specifically for storing mode of operation. The current route invalidation that happens using NPDAO had made a design choice of sending an NPDAO through the previous parent. So this is the existing mechanism. I'm not going to go into the details of this mechanism here. It was already explained a lot of times before. So there is a new message that has come into existence, the deco, which is essentially invalidating the route downstream. So all the DAO messages till date, except for DAO projection, were going upstream. This is the first time, and apart from this, DAO projection is the other place where DAOs are now sent downstream as well. Okay, so the implementation report, this is the statistics we have. So we use deco only in context when the parent switching happens, but there are other cases where NP-DAOs are sent, and those are, for example, the route lifetime expiry, and we haven't really changed behavior of that because it still makes sense to use NP-DAO in that particular context. So essentially what I'm trying to say is, currently in the example implementation that we have deco and NP-DAO operating at the same time in the same network. But having said that, parent switching is what happens most of the time, and the route lifetime expiry also is there, but in that case it's just a DAO. So in case it has to update the route, if it knows that there is the previous path, the existing path is already sufficient, or it is already there to handle the route invalidation, then it will be made use of. If not, then the new path, whichever it has chosen, will be used for route invalidation. So there is some data here. I think all of it is pretty much self-explanatory. There is further scope for improvisation here. The DAO input and the DCO input, this particular code almost is redundant. I would see that there is a scope for refactoring there. The performance report was sent a month and a half before on the mailing list. I hope someone has looked at it. So basically we had taken performance on two scenarios. One is the metric deterioration, regular parent switching, and in second case we had deliberately introduced some connectivity impairment. So we had used Contiki. We had all the code changes were done in the Contiki. The framework that we had used was Whitefield. So essentially, it uses NS3 in the backend. It uses NS3 in the backend so as to get realistic RF simulation. There are two topologies that we experimented with. So N50 is the number of nodes is 50, and UDP30 is every 30 seconds the UDP packets are sent. This is a snapshot of the topology that you can see that Whitefield, eventually the Ripple routing protocol makes up, and it's part of the Whitefield framework which shows up this topology. So this is an interesting point. So in the regular case, so when the network starts up, the network boots up, all the nodes are started up together, there is a lot of parent switching that is happening. So during that time, there is a lot of control overhead for NP-DAO as well as for other Ripple control messaging. So we have found that these particular numbers were exceptionally surprising for us. We found that there is a big difference in the overhead with deco with compared to NP-DAO, and this is not what we had thought would result in. It's actually a big improvement, but there is one reason why this has happened. In the subsequent slide, I'll try to explain. Our primary intention was to work on reducing the stale entries count, and you can see that there is a steep gradient for deco. In case of deco, if you see the number of stale entries are much lesser than when NP-DAO is used. It's natural that NP-DAO makes use of a path which is suboptimal, so it's going to be bad by design. It's bad by design. So deco improves on it, and we can see that the amount of time that the stale entries linger is much lesser. This particular difference I'm going to explain in the subsequent slide, because this is quite a surprise for us as well, and we try to understand why it has caused such a big difference. Second case is the connectivity impairment. Please note that the Y scales are not same as in the previous diagram. So still there is a big difference in terms of the control overhead with regards to NP-DAO versus deco. The parent switching, the stale entry statistics have improved, but not as much as as you can see as in the previous context. One reason is the stale. So what we had done is one of the problems that we have faced in this context is the subdudag has to be updated. When a parent switches the path, in case of storing mode of operation, the subdudag has to be updated. The subdudag routing entries have to be updated. That doesn't happen so effectively. So this is in fact one of the things that I had presented previously in yesterday's meeting. So because of that, there is some further scope of optimization here. Okay, the important observation that I wanted to mention here is why the difference in the control overhead. So if you see the current implementation or the current mechanism, this is I don't think it is implementation specific thing, but you can have a better implementation. But currently the Riot and Quantic implementation does it this way. What it does is on parent switching, it invalidates the current route. So it sends an NP-DAO on the previous path, and it schedules a regular DAO to update the new path on the new path, of course. So what happens is, since NP-DAO is sent first, it reaches all the way to the border router, and there's a lot of control over it.
Pascal, how it's the nth case where you present Quantic or open source implementation as repo. It's not repo. This is a big mistake.
But okay, so what I try to reason is it possible to handle the implementation in a different way? It is possible, but it requires some more state information. So what implementations are doing is trying to take a easy way out. It's not necessarily bad. It is saving some state information for them. So essentially what an implementation could have done is they could have scheduled the NP-DAO, added a timer here, and then scheduled the NP-DAO here. That would have been possible, but it adds up to the memory. And so I can see why implementations are going that way. It makes, even if you, so this has to be sent after a delay. There is a delay DAO involved here. So this has to be sent after a timer, but this is sent as soon as you do a parent switching. Unless and until you have a timer and that timer somehow expires after this. Now this is a randomized timer. So again, there are a lot of ifs and buts there. It's actually not very trivial to implement this in an efficient way. But anyways, coming back to the point, so this is what the root cause that we found out, why the difference is such large. We were not expecting such a big difference in the control overhead. So, but this is the primary reason. Maybe what I'm trying to say is, it's an implementation specific issue also here. So maybe the difference, it's not good for us to get excited that, you'll be saving a lot of route invalidation traffic. So it's an implementation. So how does Deco help here? So what I'm trying to say is, in case of Deco, the implementation is much more at ease, because you now don't have to initiate a route invalidation from the target node itself. The common ancestor cares of it. It's a synchronized operation. One more big problem with the previous point was that the NP-DAO was sent, it clears out the route in the previous path, and then it's an asynchronous operation, so there is a scope for route downtime there. Yeah, Pascal?
There is a need though. If you're spanning your DAO, like I'm forming this new DAO, but I want to have multiple parents, right? So I'm actually sending the same path sequence to two parents, but one is slower than the other. And what you may be doing, and beware because that's tricky, you may be sending those two DAOs and one is faster, and now you trigger a DCO too quickly.
Correct.
You don't have to hurry. Correct. But if you do it too quickly, they will cross.
Yeah.
And hopefully the sequence number game will sort it out. But I mean, you clean up a path which is still valid till it's reformed. All I'm saying is, having this broken path for a little while doesn't hurt so much.
Okay.
So don't be too quick. Just it was too quick to send the DAO, the no path DAO down, well, traditional no DAO up. Don't be too quick in sending the no path DAO down, because you might similar issues.
Okay. Actually, there is a section in the draft which also talks about this. There is a possibility that the same target node might send the same DAO from two different paths, and how that should be handled. Essentially, the path sequence takes care of it. So yeah, it's through this slide, what I wanted to bring out is that for the target node at least, or the overall operation of DCO versus the regular DAO is much more synchronized.
And then there's another thing which troubles me forever, because and maybe Alvaro we will save our life here, but this is a traditional thing in link state to kind of, well, some people have tried in the past to clean up, the bad state that's left over for some reason due to mobility, for instance. You've got an ISIS network and you've got a guy moving from here to here. And you've got this old path which stays there for a while. And people want to go and clean it up. I forgot the name for pruning this. There is a term for that. And I just know from hearsay, because I don't have experience in that, but it's always proved to be quite complex, at least in their networks. Our network is a bit different with north-south, etc. But I would like to make some research about why pruning in some other types of networks, doing this exact operation has proved to be difficult. Part of what I heard is that how that intermixed with newer, information, things change back, etc., and then you end up pruning something which is actually good. I think your explanation, the sequence number, etc., I think we're safe. All I'm saying is there is a very, very bad history of trying to do that in other routing protocols, and I don't have all this history.
I'm not exactly sure what you want to say, but yeah, in other Elixir protocols, you flush stuff. Just looking at that about one node not sending the information, the big problem is, of course, detection, right? But the other big problem is flushing something for someone who's not there. Yes, that's the problem. The problem in Elixir protocol is that you own your LSA or LSP, and only you should be the one removing that. But if you go away,
Right.
there's no one there, right? So no, so what ends up happening in Elixir protocol is that the LSA stays there until it types out. What fails is the connectivity check. Because your neighbor would say, I'm not connected to you anymore. And even though you say you're connected to me, we can't verify that.
Let's say the guy, so try to clean up a proxy, right? And then the guy comes back here or somewhere, and then you get some kind of collision between, the guy coming back. And I think that's where, the most tricky piece lives. Now, we just discussed it, and I think we're safe.
Yes, exactly. So there's no real magic or solution that would really help here, because it just depends on the connectivity. And yes, there are cases where you're connected to me and you move, and I haven't realized that you left. And so it looks like you're still here, but you're really somewhere else, and everyone else is going to see you in two places. Right, exactly. But no, there's no other way to solve that. There have been proposals on proxying, but no one has been too happy with that, because that means that I could remove your LSA for whatever other reason, right? Not necessarily just for mobility. So that becomes very dangerous in a link state protocol.
I feel that it's really linked to ISIS and OSPF. I feel that we are safe, right? Okay. Just keep a flag. I mean, should we experiment a while before we hot, that into an RSC? The most, thinking and about this sort of interaction, but I think we're safe.
Okay, so just one point to add here. So you mentioned that the target node actually owns its own routing entry. So there's one section in the draft which talks about it. So what it does is it says, so the regular DAO that is sent here, it sends a flag saying that, okay, you invalidate. So if you see this flag set, only then the common ancestor will go ahead and do an invalidation. So it sort of still is controlling in some way. So it was not needed, but we still kept that option of having that. Yeah.
So anyway, as Alvaro said, I mean, it's not somebody making the decision. You're not there. I mean, we have that as well, but it's much later. So all things are fixed before it's the parent times out. But it's still a message from the real guy, which flows up and back. It's still the message from the guy. So it's still on this state, even on the way back.
Okay.
I think we're safe.
Okay. All right. So that's all. I think we have not made any semantic changes for a long time. In fact, since the version 1, we have made a lot of syntactical changes. We have changed the message types and all message codes. Earlier, we were trying to use a flag in an NPDAO message, but then we changed to a new message type altogether. It's called DECO, Destination Cleanup Object. And that was the major change. That's all. So it has been quite stable for some time. I would like to see the next step for this particular document.
I quite agree.
It's part of the milestones. Thank you.
Do you want to have a new version of the document given the input you got now?
Yes,
Okay,
there
so-
will be one new version.
Exactly,
Yeah,
very
I'll
good.
do that
Okay.
as soon as possible.
Another question I have, the measurements you have, will you put them into an appendix or will they be in this different, separate?
Okay, the measurements, I right now have it on public GitHub. This is what I sent on the, but what would you suggest? I'm not sure. Should I
If you
keep
have
it
a
in the
separate
appendix?
publication elsewhere where you do this, I would refer to it. And otherwise, maybe a summary in an appendix would be
Okay.
nice.
Okay, all
That's
right.
my opinion.
I see. What did?
I'm sorry, I was working and
So
missed
the
the
performance report, part of the performance,
appendix is good. I always
All
have
right.
appendix like that. I mean, me, right? Two things. Cisco has IPR on this. I think Huawei as well.
yeah.
Right. So just
Yeah.
for you to know. Second thing, Raul invited me. So I said yes.
Yeah, I've-
On the view of the
There are a
IPR,
lot of-
because I have a patent which actually issued, which describes all this, and actually a bit more. So in the light of that, we decided to work together.
Who's ready to review this document? Yeah, great.
Thank you.
Well, there will be other people, I hope, on the mailing list. Yep.
Thank
Okay.
you.
And there will be a shepherd. Yeah. We really love you.
Okay, so good to hear. Yes, the DAO projection, good thing we are out of time because I don't have much to say. Apart from the fact that some people are actually implementing it. I'm aware of 2 implementations on the way. I actually invited the authors of those 2 implementations to participate to a draft because James and I were also an implementer. We were kind of alone on this and we wanted, a new eye and we wanted more review and practical implementation feedback, etc. So those 2 implementations that I've heard of one is coming from Huawei and that's led by our usual suspect here. And so apart from Raul, there is also Matt Gilmore from Itron. And so he was there yesterday. Somehow we are missing him today, but I also invited him because of his experience on how that happens in the real world. So what's very good with this news is that we have real implementations, even 2 of them, which is one of those things we want to check. So very happy with that. Otherwise, the news is we didn't work a lot on it. There were many things which are moving, so this one did not get to move too much. Let time for the implementers to implement the stuff and feedback. We have one problem that we'll have to discuss at some point, is the size of the mode of operation. The mode of operation is 3 bits, and we've got 0, that's the collection tree, we've got 1, 2 for storing, non-storing, and we've got 3 for storing with multicast support, and then we've got 4 for the RFC 6997, right, the P2P. And I guess AODV, you're using a new mode of operation as well. So we'll be short on them very soon. And so for the DAO projection, is it the right way of signaling things? How do we tell the network that we are doing DAO projection over whatever mode it's doing? Is it through bits in the mode of operation again? We'll end up consuming them all. What's the way? It could be a new option or something, and basically the Ripple network works a certain way, storing, non-storing, and then we have projected routes, which can be storing or non-storing, both of them in any of the main modes. So should we be using MOB for that, or should we be using something else? How do we signal this? That's the piece which leaves me a bit, that's a bit tricky, because we don't want to consume those mobs so easily.
I'm Charlie Perkins from Huawei. This came up in the discussion for AODV Ripple as well. Should AODV Ripple be using a different mode of operation, or should we just rely on using different message numbers and message option numbers for our operation? And if it's really getting to the point where we should conserve mode of operation bits, then that we should discuss exactly how the information is organized.
No, we have very few of them.
You're not?
we have very few mobs, right? We have 8 of them total. And we have hard consumed 4 of them with the main spec. One of them is consumed by an experimental, so we could get it back some point, because now we've got the non-experimental version of it, but we should, allow some churn, so we should not steal from the experimental, but we should recycle it someday. So that gives us at least 5 with AODV. And I'm fine for AODV to consume 1 mob, because it's so important, but not for projection. I hope we could find something else. But that's on the table, right? We've got this stupid, quote unquote, non-technical problem on how to signal DAO projection. Oh, well,
Can you ask the question on the mailing list, because we have very few people now? And
yeah.
okay. Yeah. Okay. Fine.
So, and then, that's the same question as last time. The way we differentiate storing and non-storing right now, it's done implicitly, but looking at how basically the message is formed. I don't like it too much, but it was for map conservation. So it's a lot of text just to explain, if the message looks like that, it's a storing. If it looks like that, it's non-storing, what you put in the target, how many addresses you put there. I don't like that, it's indirect. That's really when we added the non-storing piece. So then again, it's all about signaling. What's the best way to signal we are doing this? And then I wanted to share this remaining question, and I guess we know the answers. How is the topology known to the root? In non-storing mode, the root has the DODAG. It doesn't have more than that, doesn't have sibling links, for instance, but it has the DODAG. So we can already work like that. In storing mode, there is no topological information, but I think the big point is whether the root has something or not. It's not this document's problem. If we want to talk about topology and exchange things with the root to let it know what's going on, that's interesting. That's this kind of work, but it's not this spec. This spec is just about DAOs. So it has to be done maybe, but it's to be done elsewhere. That's pretty much what the answer would be. Please react if you don't agree. Same for node capabilities. We could extend the DAO, for instance, to place some memory, and there are other drafts which are already extending the DAO to say things about the nodes. So that's interesting. That's useful for this draft. Is it this draft to specify? Maybe not. We could leverage the other drafts that we are working on, which expose capabilities up there. Should we support mixed modes? Is it too complex?
Rahul Jadhav. So regarding the topology known to the root, you mentioned that in case of non-storing mode only it is known.
We know the DODAG.
We know the DODAG. So it is possible to know even in storing mode of operation, because the transit information contains the parent address. It uses, which also can be populated in case of storing mode of operation.
Yes.
And it can still be known.
That's right. I mean, with the current way of storing mode, you don't put it, but if we said put it, then all of a sudden, yes, the DODAG would be known by the root. I mean, it's easy as that. Yes, I agree. Yeah. Well, you would have to, since it's a storing mode thing, I would not do it that way. I would basically send a DAO to the root, a non-storing DAO to the root in the same network. Because if you do it to the parent, you double the memory on each hop, because they have to remember this to set it up. Remember, you cannot just flush a DAO that you got from bottom, send it to top, and forget about it. You need to keep a state and be able to rebuild it. We had this discussion. I understand constraint node have trouble with that. That's why they don't do storing mode. If you do storing mode, do it well. If you do it well, you must be able to reconstruct a DAO on behalf of the guy, because you reparent and you want to tell the new parent about it or anything else.
Right.
And that means doubling this information.
Yeah.
There's a cost. I mean, but yes. And the other thing is, if you get, fan out and you get multiple DAOs, from multiple children about somebody down there, you have to keep that list. It's okay. I mean, normally you keep adjacencies, but now for each adjacency, each child, you need to keep the pair, target, transit, more memory. That's pretty much it. So we've got those questions. Like I said, this is probably a different document. The topology should be inferred by some other work. The node capabilities are probably another work as well. It's interesting, right? How many routes can I put in that node? Can I push in that node? We are working on putting new metrics, remember yesterday's discussion. So as we build information so that the DODAG root knows the load of his own DODAG, there could be information like that coming from the nodes. But I think any information that we did here could be in those documents, because they will really be talking about metrics about the node so that the root knows better his network. So it's not this document either, that's what I'm getting at. Mixed mode, is it too complex or not? Well, we have 2 implementers now co-author of the document. So I hope we get more feedback on that. Mode saturation, I raised the point because that's the biggest issue. And then compression, the answer has always been, we'll do the compression someday for even main ripple. We never did it. So we'll have to figure one day if we want to compress the ripple signaling. I think we should do it. And then there was a question by Raoul about loop avoidance. And actually part of the things that Raoul accepted to take over in this document is to have a new section about loop avoidance. Make sure, because now we are building multiple topologies. We have the main ripple topology, and then we have all those overlays, which are the projected route. They are really overlays over the main route topology. And could you be building loops? So there is some text, there is some thinking about making sure we never build loops, but we want to study that in greater details. Okay, and that's it for me. And all the rest is backup slides. Okay. Am I in time, or did I?
Oh, no, very good. Just one question, a very stupid one. Maybe you could reduce the document only to non-storing mode and avoid all the storing mode problems?
I mean, even if so remove the original thing, which was storing mode. Mm-hmm. Well, because are you talking about the overlay, or are you talking about the underlay? The underlay is the normal ripple, the big thing, and then the overlay is the projected route. The overlay is either storing or non-storing. You're talking about that, right? Mm-hmm. And you're suggesting that only the non-storing makes sense.
Mm-hmm.
You can
not make sense, but is possible at this moment.
So the answer is no.
That's awesome.
You have another question. Okay, so the initial motivation for this work was, I have a non-storing world. And I'm building some networks where you have long lines of devices. And you want to compress along that particular long line. And so you will send a DAO at the end of the line, which will come all the way to some good place at the beginning of the line. And the packet will be source routed to the beginning of the line. And then just along this line, you'll have a single DAO state. And it's a storing mode, otherwise you lose it all, right? Well, most of it. So you could kind of do a weird thing, but it could actually do something. It would help. You still can do something that helps, but the storing mode looks like the right idea there.
The question was, do you actually want everything in the root? I mean, is there not enough information in all the other roads to handle the problem? Because that was one of your questions. How could they get all the information to the root? And I was thinking that maybe you don't need it all in the root, but it can be at the lower level things you could have enough information.
Yeah, I mean, so far, there are only 2 types of node in a ripple network. There is the root and there is the others. And the others are all the same, so they can intermix in some fashion. Now, if either you have a third type of node, which is like something in between, which could have some of those capabilities, or you will have every node capable of doing what you say. And that's a good question, but I mean, pushing, we always wanted to have ripple minimal, almost, we can discuss what minimal is. I did this morning with Charlie, but we wanted the nodes to have a minimal thing. So if you give them all this capability, yes, it's technically doable, but it kind of means that every node in my network can do it. Or I enter this third type of thing, and I have to deploy the right place. And yeah, maybe, but you see what that carries. Other question?
How will we continue with the document?
Sorry?
How do you propose to continue with the document?
Well, Raoul, please come to the mic. We discussed with Raoul about, what you would be editing. Mm-hmm. And the loop avoidance is one, so let's have Raoul.
Yeah, so loop avoidance, Raoul Jadhav, Huawei. So loop avoidance is the section that will be updated in that particular document.
Okay.
Well, there was another thing, right? I don't remember, but there were two things that you want to look at. You don't remember either, so we are good. I also would like to maybe look at an appendix, which is already a return from implementation and early testing, like something which would tell us what we're missing in report because we had nothing at the time, which would tell us more details on how to use the applicability statement, if you like. So some beginning of applicability statement. When do we see that we'll be using this? If somebody already tried it, what kind of finding he got. So yes, because we'll have implementers now, I would like some written on where and why and how, and that would be just appendix text, I guess. But we saw with REPL that having no information at all like that actually made the implementation much harder, and people now complain that REPL is hard. I mean, in my mind, it's so simple. So that's really because we did not explain enough. So when we want to turn REPL into an internet draft, we'll need to be much more clear about what things are and how to use them, even if it's an appendix. Huh?
We need reviewers for this document.
Yes. You think the last one?
Yeah.
Yeah.
We need. Yeah. Mm-hmm. Yeah.
Hello.
Hello.
So I guess you want to ask a question.
Yeah.
What is the status?
No, what are your plans?
Okay, I'm Dominique Bartel. Is Chunk on? Oh yeah, okay. If you want to join, feel welcome. So GIS modifications. The draft hasn't changed for maybe a year, I think. I just want to give you, people were asking, and we had an exchange on the mailing list since yesterday, I think, or this morning. We got comments, people were wondering what happened with this book. So yeah, I'll just let you know. Originally, I think I proposed this modification first at the Maastricht meeting. When was that? 2010? 2011? Right. And at the time, I mean, this was my main focus of work at my company at that time, to work on mesh networks. And I was really into that. At the time, I faced opposition from some originators of the RPL routing protocol who didn't want their stuff to be changed. Especially one thing in the DIS modification is that it touches slightly on the trickle mechanism, and trickle was something heavily defended by its father. And also for those who've been long enough in the working group, you remember probably JP Vassar, and he told me, yeah, right now REPL is trying to establish itself as a routing protocol in this area, and we'd rather keep it stable. Don't introduce changes, maybe don't say you can make it better, because people would understand it's not good enough the way it is. And so actually at the time he told me, yeah, put this aside for a few years and come back. So I did that, just that, put it aside for a few years, and then my company's focus changed. And so right now we're all the craze is in LP WANs and star topologies, and my manager does, wonders why I should care about mesh networks at all. So that's why it has been this way. The pendulum will swing back. Now I hear my CEO saying mesh network is the new stuff. You know, you should really be interested in that. Okay, sounds good. So we have a chance. Right. So, so this has always been in the back of my mind that, you know, we had this stuff on the shelf, and I figured if nobody is interested, why bother? I have to do that on my spare time and hide away from my manager. But now we get a sense from a few of you that this is really needed. So if this is needed, I'm more than happy to revive it, and Cenk agreed to work on it again. So we'll be polling for your use cases and make sure we do it the way it's useful to you guys, because right now it's not directly useful to me. Is that...
Pascal here. So yes, there was little on the mailing list because a lot of the discussions we had was kind of IETF type corridor discussions. But we actually discussed this draft several times since, right? And at least you and I. And I remember, I don't have all the details, I have to rebuild them because we did not capture them, it was a corridor thing. But there are cases where it's a very good improvement and cases where it will actually work the other way. And, you know, depending on how the broadcast, how many people are on your broadcast domain, etc. So it's a mechanism, and it's useful when it's useful and not when it's not. So the problem is, it's not like it's always useful. At some points it can become detrimental. We discussed that, if you remember this discussion. And so really I think, I mean, the bits are very simple, everything very simple. It could fly through this working group. But what's really needed and missing is, here is why it works, here is what it does, use it in that case, but if you're in that case, don't use it or tune it differently. That's really the tricky piece of this draft, I think. And I agree with the history. At some point at the beginning of Ripple, we want it very, very stable. Let's learn from what we have, which we did over the years. And now since we learned, it's the time to do version 2, clarify the text which is not clarified, which is what House draft yesterday does, etc., etc. So at some point we can turn it to an internet standard. So this would be needed for the internet standard, but with all the right words, which explains why and when you do it, and when you don't do it.
Right, so the intention is to introduce the flags and bits so that you can tweak the way DRS and the IOs that you get in response are triggered. Now, so yes, we're opening ways by which you can make the network really bad, and hopefully people will learn how to use that. So, I mean, how to use it the wise way, such that it makes the network better.
So either we document it in this spec, and we have all the information, the protocol, etc., in the environment to use it well, or we make it experimental and we do the learning.
So
if we don't know already, then we need to make it experimental because it can really work the wrong way.
So back in those days, we had a real use case. We had a real experiment, and we could, you know, show that it worked well in the field the way we wanted. Yes. And then it was merged with another draft by Mukul, which was a different situation, and they wanted things different. But we figured, you know, it's just a matter of specifying what we want in the DIS using a few flags and constraints. And so now I don't have the deployment situation to test all those cases. So I will not be able to justify why it makes it better in this and that situation. I need your use cases.
I mean, we discuss, I mean, we have to rebuild this information now. I don't have it out of my hat, but I really remember that depending on density and what and how things are built, this could actually cause a lot more traffic than doing the normal way. It can really be useful, like a node coming in an existing network, etc. It can be really detrimental, maybe informing a very dense network. I don't remember the use cases or the cases, but really we have to look at what we discussed that day and make sure that we use it when it's good and not when it's not good, and we provide the information to know when it's good and when it's not good. Because a basic node could be hard-coded, setting those bits just for the pleasure of it. And depending on when you place it and when it does that, that could be good or bad. And I don't think that's right. I think we need those bits, we need this work, but we need to make sure everything is in place so that it's used when it's needed and useful, and that it's not used when it's detrimental. And I quite convinced we discussed that there are cases like that. So we can work together on that or with Chang.
Okay.
That
Again,
must be in the
I do
document.
remember the use case that we had in mind. I'm no longer in a situation where I can actually run it, or I may become again in the future. And I know there were people which had different use cases, different topologies, which I'm not too familiar with. So I can design the mechanics that has a bit that you can turn on and off, but telling which is best in which situation, this is kind of out of my reach right now. I can tell for the one situation that I know. So if anybody else wants to join the work and run simulations, experiments with various topologies, that's fine with me.
I think some of that was really kind of obvious by when you run it and what you do. So we need to redo that. But yes, after that, practical implement information could be useful. The case I remember were much simpler than very complex runtime thing. It's just basic, like who's flooding what and how much flooding that results in. So let's take it offline.
Okay, so yeah, we promised with Cheng we'll allocate some time on that. Same thing for Cheng, actually does not work on this anymore. I understand. And other people have left the field as well, Emmanuel and Mukul and all those guys. So we promised to allocate some time to revive this, have a discussion going on the mailing list, and come with some draft for next meeting. I'm not too sure what will be in the draft, but at least we'll raise awareness again.
Did you receive enough motivation? I mean, that was one of your major points. You didn't see enough interest in the draft.
Yeah, Cheng sent an email and we got 3 replies in a matter of hours. People saying, yes, this is interesting, we need it, we want it. So I consider it a good enough support to get started. Now it's just a matter of resource allocation.
Okay, very good.
Yeah,
Nice.
and as you know, if we are not too clear, we can always make it in 2 steps, right? Have this experiment also people implement it, return, and now we could ship it very, very quickly. And then as a second stage, just like we did for the P2P, then do the real thing. And it could still be you, but that would be first an experimental and then a standard track once we really know. So we care for the standard track because we'll put it back in the internet standard. But at this very moment, we are not close to an internet standard with Ripple. So you have a window of time to learn and get more feedback. So the alternate way, if we want, not to have too many things in parallel, this one is a great experimental RFC publishing tomorrow morning. Because it's been there forever, it's been tried.
Yeah, I know.
And if we just set bits and use them and tell us if it works and what it does for you, then publish it as experimental tomorrow morning.
Yeah. But I don't want to publish tomorrow unless I get an okay from the authors that they agree with the contents.
Well, we can always reduce the content and so we can publish. If gets something done, I'm fine with that.
Yeah. Okay, some other comments, conclusions, suggestions? Okay, so we're closing. Thank you very much for attending this meeting, and we are closing and keep the conversations in the mailing list. Thank you very much. Have a nice day.
See you in Canada.
No, I don't see it.
Ines will not see you in Canada. Yeah.